Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about how to use Nakama with Godot. So we're going to go through the basics. We're going to start with what is Docker, what is Nakama, how to get it to work, what is Docker, how to get that to work. We're going to talk about how to set up accounts. We're going to talk about how to do user management. We're going to talk about how to do matches and matchmaking. So lobbies and matchmaking will be put into this tutorial. We're going to talk about how to do some basic configuration using Nakama, and we're going to round it out with a very basic multiplayer example where you can have two players that can run and jump and things like that. Unfortunately, this is going to have to be a one of two, possibly three series just because of how much stuff Nakama gives us. But this tutorial can be used as a base to get you started. So that's what I have in store for you guys today. So let's go ahead and get started. All right, so the first thing we need to do is we need to talk about what Nakama is and what Nakama isn't. So Nakama is a multiplayer library / server that you can actually host yourself for your games. It's created by a company called Heroic Labs, and they have a lot of really cool features and a lot of really cool things that you can use. Now, if you take a look, it's one of the most popular open source game servers out there. So you can see here, it's got all sorts of features. So you can actually come in and do stuff like checking which active matches are running. You can come in and actually store data and store those people's information. So the nice thing about Nakama is it's kind of a one-stop shop for a lot of the stuff that you would normally need to build yourself. So it's really useful for that. Now, if we scroll down, you can see here, it's open source, so you can use it for your projects for free, and there is no royalties or anything like that. Now, that being said, I will talk about how to monetize their product because it is monetized in a way. So just be careful of that. You can see here it has real-time multiplayer and it has competitive multiplayer. So you can actually keep track and actually have a matchmaking algorithm that can actually match people up. Now, I believe you have to code that yourself, but they have a nice guide on how to get started doing that. Now, the nice thing is this is also supported in Unity, Unreal, Godot, C#, and Cocos, JavaScript, and I believe Java. So they have lots of different languages that they support that you can actually integrate with here. Now you can see here, here's some of the features, a real-time online multiplayer game. Now, something to keep in mind, this is an engine that runs on a server. That means that if you are going to use this, you need to actually have a server for this to run on. Now, I am going to walk you through how to do it with DigitalOcean, but just know that this is a thing and it is important to remember. Now, something that's nice about this is a server-based networking solution, not a WebRTC solution. So it's not peer-to-peer. It's going to be a build a lobby and it's going to route all the traffic. So that's something to keep in mind. So the hosting cost could be a little bit higher if you're going to allow that. That being said, I will do a follow-on that will talk about how to make this a WebRTC based connection. And then you can get rid of that little bit of hosting cost. And you'll still need to host the game, but it'll be a lot cheaper. You can do stuff like having a leaderboard, you can have tournaments, you can have leagues and seasons pass all built in. They have a virtual wallet, so you can actually keep track of all the in-game currencies and things like that that you want to sell to your people. They also have the ability to validate in-app purchases. So if you're using Google Play or Steam to purchase different assets, you can actually validate those in-app purchases right here inside of Nakama. They also have the ability for you to have player profiles. You can have friends and persistence. You can also have communication between people, and you can actually alert players with in-game notifications and have a real in-game chat. Now, I may not cover all of these features just because there's a lot here and it's a huge thing. And this tutorial would be 12 hours long if I covered everything. So just remember, I'm going to give you a brief brush and then we can go in deeper as we want. And finally, you can extend the actual game server using Go, TypeScript, or Lua. So The nice thing about that is that you can define your own stuff. So you can actually build your own things to make your server whatever you want. Hey guys, Editor Mitch here. So something I forgot to discuss was how Nakama actually makes money. So this is an open source tool and it is 100% free. You can use it for your game forever and it never costs you money. However, they do make money by hosting it for you. So if you host it on something like DigitalOcean, right? Something like this where they have their own pricing, right? Or you drop it onto like your own server or something like that. It's 100% free, right? At least on the Nakama side. Of course, the server would cost money if you're going to host it on a cloud service. But the way that Nakama makes money is by using their own heroic cloud system. So it's extremely expensive and it's really not worth looking at until your game becomes a gigantic game, right? So like we're talking thousands and thousands and thousands of users, right? You can see here, you can see 1 or 2 CPUs, things like that. You can see right here how much having them host your stuff is going to cost. $1,000 a month, right? Like let's say you have a machine that has 2 CPUs and 2 database CPUs, then you're looking at $1,200 a month. And you get a lot of benefits for that, right? Automatic system scaling, an enterprise edition of Nakama, which means that Heroic will actually work with you and they'll, support you in your game, and they make sure that everything is perfectly secure. They make sure that everything is scalable. They make sure that everything is load balanced. So let's say, you have a big influx of users. Suddenly, if you've ever seen some smaller game studios where suddenly the game becomes popular and then the servers start crashing and start having problems, well, with this, it doesn't happen, right? It just handles it and we're good to go. So a lot of times that's where Nakama actually makes their money, is by having you pay them $1,200 a month to use them as a resource to host all of their stuff. Now, again, if you don't use them as a resource, it's totally fine and it's going to be 100% free as long as you host it on some kind of machine you own, or, of course, whatever the cost of, a DigitalOcean machine or an AWS machine or an Azure machine would cost. So that's just something to keep in mind. I wanted to make sure you guys were aware as like a full disclosure so you're not confused as to how they actually make money. So with that being said, let's go ahead and jump into setting up Nakama. So this all sounds really wonderful. Where do I even begin? Well, that's where Docker Compose comes in. Docker Compose is a way to get Nakama running up really fast. Now you can see here, right here, prerequisite, you need to install Docker Desktop. And I'll explain what a Docker Compose is and how the file works and everything in a minute. But just know you need to install Docker Desktop. I have a link in the description of where you can download and install that. But Docker here is a really great tool that allows you to basically containerize applications. And I'm not going to go into like the really nitty gritty on this because there's so much to this that it would take a whole tutorial on itself just to talk about Docker. But what you should do is you should download Docker and download the Docker Desktop. If you click on products, so right here, and then go to Docker Desktop, right here, you could just click download for Windows, download for Linux, or download for Mac. So we'll click download for Windows, and we'll go ahead and download this for Windows. Now I already have it installed, so I should probably uninstall it. So I will be right back. And once it's downloaded, we'll go up here, we'll click on our installer, and we're gonna let that install. Now it's probably gonna ask me for permissions, which it did, so we'll approve it, and you will see that this is gonna pop up. Now you can see here, use WSL2 instead of Hyper-V, recommended, absolutely. and add a shortcut to desktop. So let's go ahead and hit OK, and you'll see it's going to unpackage the files. Now, what this is doing is it's basically saying, okay, we're going to install Docker, right? We're going to put that all in. But the question is, what is Hyper-V? What is WSL? And what is AMD-V, right? So how all this works is basically Docker works. Think of it kind of like a container ship, right? You have all of these big containers on top of this ship, right? And each container contains an application. That's why they call it a Docker container, is because it contains an actual application that's running. And it also contains the OS that's built into it as well. So it's kind of like a virtual machine almost. Now, just below that is what's called the Docker engine. And the Docker engine can run in two configurations, the Hyper-V configuration or the WSL configuration. Now, the advantages and disadvantages of either one doesn't really matter. Typically, WSL is a little bit faster because it's Linux, but it doesn't really matter. Just know that it's running on top of that stack, if that makes sense. If it's running into that as like a virtual machine or as like its own thing, if that makes sense. It's like its own process. And then it runs on your host OS, which in this case, in my case, it's Windows. So everything's just put onto Windows. And then outside of that is your hardware. So that's kind of how the layers work with Docker. And the advantage is that you can spin up applications really fast and you can shut them down really fast. So it allows you to do what's called scaling horizontally to make your products more efficient. Think of it kind of like this. If a bunch of people are in your game and suddenly your server starts to get overloaded, what you can do is spin up another server and then load the Docker image on it and then just hit run. And then suddenly, bam, it's running that actual server exactly as you configured it, and everything is just builds up and it's done. So it's really, really fast. It's really efficient. And it's also great for development because it allows you to have a nice sandboxed environment for your stuff to live in, which improves security and stability for all of your products. So it's just something really good to get used to and to know. And it's something that everybody is using in the industry. So just keep that in mind. Now, once Docker Desktop is installed, we'll click close, and then we're going to type Docker to open it up in our start menu. So it'll probably pop up. I expected it to pop up in the upper left-hand corner, but this time it popped up right here. So this is a subscription service. This basically just says, hey, this is a free thing, but if for whatever reason you make $10 million or you have 250 employees, then you should purchase the product and use it for that. Most of us are never going to have this problem, so I wouldn't worry about it. So we'll go ahead and click accept. Now, once Docker comes up like this, you can just hit continue without signing in. That's fine. It does not matter. And you'll see it's going to give you a welcome survey, and you can put whatever you want. In my case, I'll just say, I don't know, I'm a backend developer. May as well. And then it's going to say, what will you use Docker for? I don't know, testing applications. And then we'll go ahead and hit continue. Now, this is what Docker looks like. So you can see here you have containers, images, volumes. Now, I'm not going to give you a crash course on how this all works, but basically containers are your applications that are running, built or running currently. So you can always shut them down and start them up from here, no problem. If you see an image is basically a version of a container. So it's a thing that you can reuse and respin up new containers. So think of it kind of like if you have a class, right? And you have a bunch of stuff in this class, and then you inherit from that class, right? You get all of the properties of that class, and then you kind of expand on that class, right? And if you spin up another inheritance from the original base class, it gets all of that additional stuff. That's kind of what an image is. It's the base class of your containers. Now, that being said, you want your base image to be almost as close to your actual final image as humanly possible, just because it's a lot simpler. Volumes are basically used to store data. So don't worry about that, but it's basically just where all your data is stored. The nice thing about this is when volumes exist, that means that you can reuse them. So if you were to duplicate a volume, it would duplicate all of the storage that's associated with it. And you could also point multiple containers to one volume and share storage between containers. So that can be useful if you had a server that had 5 instances up and it all points to the same storage volume, it would all share the same information. Now, that being said, there's a lot of wrinkles with that, but just know that that's a thing and it does exist. Builds, I never use this, but it's basically building different containers and different stuff like that. So I never use it, but it's a thing. And then Docker Scout is basically just an advanced analytics system that's built into Docker. And now let's talk about compose files, Docker compose files. And now let's talk about Docker compose files. So if we head out to Nakama here, you can see here they have a docker compose.yaml file here. So if I just grab all of this, I'm going to copy it. Now in my case, I'm going to grab the Docker compose first one, which is the cockroach database. And typically, if you're going to be using it in production, you might want to pull the Postgres one. That's this one down here. But since this is not going to be used in production, this is just for my own local testing, I'm just going to use Cockroach. It's a lot smaller database. It's a lot easier to work with. So we'll go ahead and just grab this entire thing here. We'll copy this guy like that. And then we're going to go out to a folder location. So I will go right-click File Explorer, and I'm going to go into my documents. Now, inside of my documents, I'll just pull this guy over here. We're going to right-click, add in a new folder, and we're going to call it Nakama server. And in my case, I'm going to add tutorial. And you don't have to if you don't want to. Now we're going to double click on that. And we're going to click up here. We're going to type CMD. And then it's going to open up a command prompt. So I'm going to type code dot. And that's just going to open up Visual Studio Code. Now it's going to make it gigantic. There we go. And basically what Visual Studio Code is going to be used for is it's going to allow us to edit files. So we're going to hit new file. We're going to make a text file. And we're going to paste this YAML file in. We're going to Control S and we're going to name it Docker. And I believe it has to be lowercase d, if I remember correctly. If we take a look, it's docker-compose.yaml. So we'll go ahead and just grab that Docker compose YAML and we'll hit enter. Now, this is a Docker file. You can see there's all sorts of information in here. And I'm not going to go too crazy in depth in it, but just know that this is a thing, basically. So what it is doing here is it's creating a service named CockroachDB. It's pointing out an image for Cockroach. So here you can actually control what version of Cockroach you want to use. You can see here it has a command that it's starting. So when the actual container starts, it's going to run this command as an argument. You'll see restart no. That means that it's not going to reboot it. Volumes, it's going to create a data storage volume. It's going to expose these two ports in the firewall, which is the HTTP port and the actual Docker port, Cockroach port. And then you'll see that we're mapping those ports to our own internal ports. So our actual Windows system is getting mapped to these. And then you can see that they have a health check as well. So we can actually come in here and we can go to this address right here and it will check if it's up and running. And then you'll see here that we're doing the same thing but with a Nakama one. So you can see it does all the things. It does a health check. And then Prometheus. Now, Prometheus is a open source metrics and monitoring solution. So you don't technically need it, but you should have it for all of the Nakama graphs and stuff like that that it actually uses. So I would keep this, and it's very nice to have. So we'll just put that there. So once you have this, you can save that Docker Compose file and open up your command prompt in that location. So you can see we're in the C users findpoint CGI documents, Nakama server tutorial, and then we're going to type Docker Compose. Up like that. And we'll hit enter. And what that's going to do is it's going to download and pull all of those images it's looking for and all of the data it needs. And it's going to pull down all the Cockroach and Nakama and everything and get it all set up for us. And then in a minute, it's going to create all of the stuff and it's going to fire it up. And you'll see that it has fired everything up successfully, or at least it's getting there. It takes a little bit longer the first time. So you can see here, it's now done. So you can see we have a startup done message right here. If we open up our web browser here, and we go to 127.0.0.1:7351. If we hit enter, you'll see we have a Nakama console here. Now, the username is admin and the password is password. Now, you probably should change that password when you're ready to deploy this, but in this case, it's totally fine just for monitoring and stuff like that for it to keep those passwords. Now, you can see here, there's all sorts of stuff inside of Nakama, and unfortunately, I'm not going to be able to go through everything. There's just so much here that in one tutorial, it would take way too long. But you can see here that we have a status, which is node name Nakama1. So this is really good for clustering. So Nakama actually offers clustering, which is really cool. And basically, you can tell it to coordinate different clusters and throw people on different sessions and things like that. And that's a whole other ball of wax that we're not going to be able to get into. They have a process latency, a rate, an input, and an output. So this is how much data it's actually using, what the process latency is, what the input, what the output, and stuff like that is for that actual Nakama instance. If we go over to user management, this is where all of the user management stuff is. So you can see that you can actually build users for your projects. You can come in here and say, hey, I want to have an email, a username, a password, and a role of some description. Now, I'm not going to create any more users just because there's no need to because I have the admin role, but this is useful if you want to create a smaller subset of different accounts for your maintainers. So for people who are developers or maintainers or something like that, this is very useful. For the most part, if you're doing a small project, this is not going to be necessary for you, but it's something that is useful. Now you can see they have a configuration section. So this is where you change all of your configuration. So you can come in here and actually export this out and then re-import it and then change the configuration. So if you click on export right here, and I just drop that on my desktop really quick, and I open this up, I drop this guy in and I open it up. You can see this is your actual Nakama configuration. So you can do all sorts of stuff like changing the tick interval, the different IAP stuff if you have an IAP. So IAP is like Google Authentications and stuff like that. You can change your username and password right here inside of your login. You can come in here and change what type of runtime, where the runtimes are located. All of that is right here. So you can go through and change any of this. And if you go into the Nakama console, you can actually just put it right back into here, browse it out, and then drop it in. And it'll reboot all of your Nakama and take all of this into account. Next is runtime modules, and we will get through that later. But basically the concept is it's all of the extensions to your Nakama instance. And that's basically what this is for. So it's all of the special stuff that you need. Like if you want to list all of the ongoing matches for your users to see, you would build a module to do that. Accounts is where all the accounts live. So these are all the user accounts. So these are the accounts of actual people that are playing your game. So user management and accounts are separate. This is for management of your Nakama instance. This is for management of your game. That's how it's separated. So this is actually where user accounts will live. So you can see if you click on here, user ID 00000, display name, avatar, username, different types of authentication, what friends they're a part of, what groups, what wallet they have, so what kind of money they have, what purchases they've done, what kind of software subscriptions do they have, if any, and what kind of storage objects do they have that's associated with their account. All of that is really important. So it's just something that we're going to have to keep track of, and we'll run through these as time goes on. Next up is groups. So that's all your groups and group storage and group information. So don't worry about that. Storage is where all of your data is stored. Leaderboards is where all of your leaderboard information is. Chat messages is where you can see all the different chat rooms and the information that's been sent. Matches is all of the active matches that are currently running. And API Explorer allows you to explore the API and actually do different things within Nakama as if you are an actual application. And that's basically everything that you need to know about this management console. Now, I know I did a really brief overview, but as we integrate it into Godot, we will actually come in here and talk about the different features and why they're useful. Now that we've talked about a lot of the Nakama stuff, let's talk about a little bit of Docker here. So I just went through this earlier, but if you look, you can see here in your container section, we now have stuff in our little Prometheus, Cockroach, and Nakama service tutorial image here. If you take a look at the images, it's the exact same thing, Cockroach DB, Prometheus, and Heroic right here. So it shows that it automatically created all of these different volumes and all of this different stuff for us already. And if we click on some of these, you can see that we can load up that actual image here. Well, in this case, it's a container. We can load up the container here and we can scroll through its console. So it's really nice for like debugging and things like that. So that's something to keep in mind. Now, once we have this, we basically can come into Godot here and we can actually build out our Nakama integration. So we'll go ahead and create a new project, call it Nakama integration tutorial. And we'll go ahead and create that folder and I will create and edit. Now it's going to make it fully maximized on my screen. So I'm going to make it just the right size in 1 second. There we go. And what we'll do is we will come into our asset lib. We're going to type Nakama. And we'll go ahead and grab the Nova Bytes Godot 4 client. So that's going to get all of our stuff just already built for us. It's going to make things a lot easier for us. So we'll go ahead and do that. And then we'll come in and we'll basically start building this out. Now you can see we have an add-ons section and a code gen. Don't mess with the code gen. It's not really worth messing with. And you don't really need to mess with any of the Heroic Labs Nakama. But one thing that you do need to do is out in your project settings, I need you to go out to the auto load and go ahead and click on this little file icon. And then navigate out to add-ons, Nakama, Nakama.gd, open it up, and let's just name it Nakama. And that's totally fine. So we'll click add and close. Now what that's going to do is it's going to create a singleton or a auto-loaded node in our node tree when we hit play. That's going to allow us to access all of the different Nakama features and things like that. So in order to integrate with Nakama, we need to basically create a client script. So we're going to go into a user interface. We'll right-click, attach a script, and we're going to call it client.gd. So client.gd, like that. Now this is going to extend from control, and I'm going to give it a class underscore name, and I'm going to call it Nakama multiplayer. And that's basically just going to give me the ability to access this if I need to. Now, something that we'll need to do is we'll need to actually have what's called a Nakama session and a Nakama client. So I'm going to say var session is equal to colon Nakama session, like that. And then we'll say var client, and we'll make that a type Nakama client. Now there will be additional stuff like a socket. So I guess while we're here, we might as well do that. So socket, and we'll do a Nakama socket as well. Now the difference between these guys is relatively simple. So basically this is the session that you have with Nakama. This is the client, okay, which houses the session. So there's the session is kind of inside of the client almost, if that makes sense. And then there's the socket, which is the connection to Nakama. So that's kind of how this is all separated out. Now, for us to be able to create an actual connection, first we have to create our client. So we'll say client is equal to Nakama dot create client, like that. Now, your first thing you got to put in is your server key. So I'm going to put default key. And that's basically like your passcode. So I would suggest that, and that's basically like a passcode. And we could talk about how to change that later, but know that that is what that's for. Then you have your host, so your IP address. So in our case, it's 127.0.0.1, comma, and then I believe after that is going to be the port. So Nakama by default does 7350. So 7350. And then finally, we need to actually put in our schema or our scheme, right? So how are we going to interact with it, which in this case is going to be HTTP. Now you'll know if it works if you hit Control S and we save this as test scene.tscn and we hit play. You'll see not a lot happened, right? But if we drop a breakpoint right here in our pass, you can see we have an object ID here, which has all of our client information. So that's how we know that it worked properly. So now the question is, how do we actually log in, create our connection, and get things going? Well, all we have to do is basically initiate that session. Now, you could do it in a lot of different ways, but in the way that I'm going to do it is it's going to be relatively simple. We're basically going to have an email, we're going to have a password, we're going to have a session, a socket, and then we're probably going to set up a multiplayer bridge. Now, that's something that we might want to do a little bit later when we go into the multiplayer bridge, but that's kind of the steps that we have to go. So what we'll do is we'll come into our ready. We'll hit enter, 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 and we'll say var session is equal to await client dot. I wish it would give me some auto completion here, but I believe it's going to be authenticate email async. So we'll pass in an email. So test@gmail.com, comma, and we'll put a password. So we'll say password like that. And then we need to actually initiate that socket connection. So we actually need to build out our socket. So in order to create a socket, it's actually relatively easy. So all we have to do is say socket is equal to Nakama.create socket from, and then we could pass in our client. And that's basically going to inform Nakama of what type of socket we want to make. So you can see here, this is configuration information, and then this is our actual socket connection. So it's our connection to the actual server. So we're using this almost as a way to inform this on how to connect, if that makes sense. And now sockets have multiple ways of connecting. But the simplest way is to connect asynchronously. So we'll say await socket dot connect underscore async, and we'll pass in our session. And that'll basically connect our socket, if that makes sense. And that's pretty much everything that we need to do to create that socket. Now, a socket has multiple signals that are associated with it. And they're actually really, really easy to hook up. So I'll bring the signals in right now. So basically, you could just type socket dot connected dot connect, and then we could basically just say on socket connected like that. And then I could just basically create that function right here. So func on socket connected like that. Now, what this signal is going to do is it's basically going to allow me to print out whether or not my socket was connected properly. Like that. Now, we'll probably want to duplicate this for when a socket is disconnected and when it's closed, or when it receives an error. So we'll duplicate this 3 times, and we'll say socket dot closed and socket dot received error. And I'll basically just change this to on socket closed and received error. And then I will duplicate these guys 3 times, like so. And then we will change the title, like so. And then for on socket error, we can actually just pass in the error like so, and then socket error colon plus error. And I'll just make that into an str. That way it becomes a string. That way if it has any type of other information, it's not completely falling apart on us. So that basically hooks up these signals here. And these signals are used whenever somebody connects to Nakama. That's what this connect is. Whenever somebody disconnects or closes that connection, that's when this runs. And whenever we receive an error, that's when this runs. Now, it's nice because let's say when a socket gets connected, we want to go and send player information or upload user data or something like that. You could do that right here, and it would happen as soon as that connection happened. Same thing with close. Whenever a close happens, if we wanted to save information or something like that, that's more or less what this can be used for. And then if we ever run into an error and we want to pop up something for the user, that's what this section is for. So that's kind of how this builds. Now, one other big thing that it has is what's called match presence and match state. So if we copy these and paste it 2 more times, we can come in here and say received underscore match underscore presence, like that. And then we can come in here, paste it, and then do on receive match state as well. And then I'll say on match presence, on match state. Now, what these two are used for are really simple. Basically, when you receive a match presence, so when you receive that a match exists, that's what this is. Whenever you receive a match state, so what the state of that match in, if it's in playing or if the game is starting or something like that, that's what this is for. So if we come down here, we can go func on match presence. And this is going to pass in a presence, and that's going to be of type Nakama RT API dot match presence. And we'll print that presence. Now, this is for when you're doing matchmaking. So don't worry about it right now. We're not going to go too in depth into it, so it's not a big deal. But I just want to make sure that we put it in so that way it exists, because sometimes people want to use the Nakama networking system and sometimes people want to use their own networking system. And I don't want to leave you guys stuck with not knowing what is available to you. And for on match state, we'll copy that. We'll come down here and say func on match state, and we're going to pass in a state. And basically that's going to be a Nakama RT, so Nakama real-time API dot match data. And that's basically just the match data of our project. So print state, like that. That's just going to pass in that information. Now, again, this is only if you are using the Nakama matchmaking system. So just keep that in mind. Now, once we have this, we basically have our socket connection completed. We created our client, we created our session, we created our socket connection, and then we connected to that socket and then configured it with our session and basically connected up our signals. And that's how you start with this. So if we hit play, you'll see in a second, it's going to do this. You'll see this right here. Nakama debug, sending request ID 1, account authenticate email. So we're authenticating our email and we successfully authenticated. We're connecting to our host right here, and we created a unique WebSocket address, basically. So we have that connection, and we are now connected to our Nakama instance. So that's primarily how you actually do the connection. And I know it's kind of confusing, but you can see if we go into our Nakama console, we go to status. If I relog in, you'll see we have one session. So our session has been connected. We actually created our client and made it so that they exist. And if you look at our accounts, you can see that because we didn't have a user account called test@gmail.com, it created a user account. And the user account's name is this random string of information. And they do that because they want you to have a unique username. If you were to make it test@gmail.com or just test or something like that, it could cause problems. So that's one of the big things that Nakama tries to do, is it tries to work with you instead of against you. So once we have ourselves connected, now what? Well, first things first, how do we set our user's name? Because you can see we have a display name, we have a location, we have a username, avatar URL, time zone, right? How do we set that information? Well, that's relatively simple. If we head over to our Godot scene here and we come in here, let's go ahead and actually update our user information. Now, in order to do that, it's actually relatively easy. All we need to do is basically just do a update account async. So what I'm going to do is make a function for that. So I'm going to say func update user info like that. I'm going to pass in a user name. I'm going to pass in a display name. I'm going to pass in an avatar URL. I'm going to make that equal to quote. And then I'm going to go ahead and do language. I'm going to make that equal to quote en. And then I'm going to do location. I'm going to make that equal to US just because I'm in the United States. And I will say time zone is going to be equal to EST. Now, what this is going to allow us to do is it's going to allow us to update that user information. So then we can go await client.update underscore account underscore async. And it's mad at me. So I'm going to scroll over, take a look. And I got an extra M there. So we'll get rid of that. Does that solve our problem? It does. And I'm going to pass in the username, comma, display name, comma, avatar URL, comma, language, and the location. Actually, I think it goes, yeah, location, and then I'm off by one. So hold on. Avatar URL, language tag. So language, I feel like I'm off by one. So we got username. Oh, I'm missing my session. Okay, so we'll pass that in too. So we'll say session, then username, display name, avatar URL, location, and then we'll pass in our time zone. And basically, all we have to do is just call this. It's really quick and really easy. So we just type use update user info. We could pass in different information here. Now, of course, we're going to want to make this into like a section where the person can fill out a form, but I'm showing you guys how to do this, I guess the hard-coded way, and then we can go from there. So when we update our user info, I'm just going to pass in test, comma, test like that, because I only really want to show the display name. Actually, I'll do test. Let's do this. Quote test display like that. And then we'll hit play. Now this is going to run really quick. We're going to authenticate with Nakama. And you will see in a second that if I go out to our Nakama console here and I go to our accounts, you can see we have a user ID with a user name of test and display name of test display. Now, the reason why this is nice is because if I rerun this really quick, let me log in real quick, and I put a breakpoint on my process right here. If I go down into my client here, I believe it's client, it looks like it might be my session. So if I go into my session, I can pull back my username right here. And you can see here, I've got a token, I've got my username, so I can actually pull that and use it. And if I take a look at, I believe it is my... And so this can be really useful when I want to get my character's username, right? So that way I can have their username. So that's really nice. So that way we can actually display that information if we want to. And that's kind of the really big benefit here. Now, in order to pull back the user information, all you really need to do is just say var account is equal to await client.getAccount underscore async. And then just pass in your session. And that's basically going to pass in your session token and it'll pull back all of your account information. Now you basically could just come in here and print that out. So print account. And you'll see when we run this and we log in, you'll see that we get back this object here, right here, this little bit right here. And this has all of your account information. Now, the nice thing is it's going to have your wallet information. It's going to have your username, display name, things like that. So if you were to come into here, you could actually come in, right click, add a child node. Let's add in a label like so. Let's just throw this over here and type user account. And then I'm going to duplicate it like that. I'll pull it over and then I'll put user account as well. I'll just put user account text. I think it's best if I do user account text like that. If I take both of these guys, duplicate them, and I pull this down a tiny bit, I can call this display name and then display name text like that. And then I'll do user account label like that. And I'll just put this as display name like that. And we'll put user account with a capital A. Now, when you pull back this user information, all you need to do is go into your script and basically just say, if we take a look at the data that this actually has here, you can see what it looks like. So we could just say $ user account text is equal to account dot, and we can find that user account. So in this case, it's going to be username. So username. And then we'll do the same thing, but for the other text as well. So display name text. And then we'll change this from username to display name. Like that. And now if we refresh this, when we log in, it should, well, in this case, it's invalid get index username. So let's take a look at our account. It is going to be under, let's see, custom ID, devices, emails right here, user. It looks like it's under user. So it's going to be account.user.username, account.user.displayname. And you can see that it has all sorts of information here. So if you had like their Google ID, their language tags, their location, their Steam ID, if they have a Steam ID, and their username. So there's a lot of information here that you could pull. You can also pull their avatar URL from the network as well. So if you were to drop something like this in and then use storage, you could actually store that URL, that avatar out there and pull it back out and then load it and display it. So we'll refresh. And you'll see it says user account is test and display name is test display. Now, I am going to come in here. I'm going to grab these two guys. I'm going to pull them over just a touch. And then I'm going to right click add in a panel. Just because I think it's best for us to put this into some kind of panel here. Now, we're also going to need to make a slight adjustment with our login system, right? Because we need to make it so it's actually flexible enough that people can actually use it, right? Because right now it's not really useful the way it's set up. So what we'll do is I'll put out this panel. I'll come in here. I'll change this to panel / account text data. And then same thing here. So panel / display name text. And there we go. Now, to be able to adjust this and refactor it so that way we can actually use it for logging in, we basically just need to pull all of this out and then just authenticate the other, set up our authentication. So I'll just kind of grab this bit here. I'll cut it. I'll come into my control node, add in a child node. Let's add in a panel. Let's bring that panel over here like so. And I'll just bring it, I don't know, back here like this. I'll right click add a child node and we'll go ahead and add in a label. We'll call it user email like so. We will control duplicate that, pull it down. We're going to right click add a child node, add in a line edit like that. And then we'll just drag this guy over here, pull it over. We'll grab our label as well, control duplicate, pull it down. Grab our email, change it to password, like so. There we go. And then we'll want a button for submit. So we'll right click, add in a button, like so. And we'll do submit, like that. Now, I'm going to name this line edit email input. And I'm going to name this line edit password input. And then I'll go to node and I will grab this button. And I'll say on button down. And instead of button right here, I'll say log in button like that, and I'll do button down, and that'll give us an on login button down. We'll go ahead and connect that, and then I'll just come in here and paste that stuff in like that. Now, when we want to do our authentication here, I'm just going to change this to be the $, email input.text, and then same thing for our password. So $, password input.text like that. And that'll basically abstract all of that out and make it into a reusable system, if that makes sense. So we'll hit play, and you'll notice that nothing really happens down here yet. But when we go test@gmail.com, password, and we submit, you will see that we successfully log in and get back our data, and we get all of our information right here. So that's basically how we create our login system. So next, let's talk about how to store data, because one of the big things that is important about Nakama is being able to store and back up information. Hey, editor Mitch here. So something else I neglected to mention inside of this tutorial, you'll see that I have a lot of stuff here, just ignore all of that. But something that I neglected to mention is if you look at the login system here, we actually have multiple things that we can do here to do logging in. So first things first, we don't necessarily need to authenticate via doing user account and stuff like that. You can see here, we actually authenticate via email right here and then set up our socket. We actually can go and not do it that way. If we comment out update user info and we come in here and comment all of this out, so Control K to comment, and then we comment this guy out as well, we can actually just do what's called a device authentication. And all that is a unique identifier and authenticates with that identifier. So if we just do var device ID is equal to os.getUnique ID like that, and that'll pull back a unique identifier. And then all we have to do is say var session, or actually we don't even really need var, we could just say session because I have a global value for that. Await client dot authenticate, and you'll see we have a bunch of different options here. If we just do authenticate device asynchronously, we could just pass in device ID like that. Now they do have other options in here. If you take a look, they have username, create, things like that. You can see if I pass in null, comma, you'll see that they have create, so we'll say true, comma, and you'll see that they also have vars, which are your variants, okay? Now, what all these means is relatively simple. Null, if you want to add a temporary username to somebody, you can do that. True is if you want to create the values, and then vars is if you have any additional values that are associated with that device, but you don't have to have that. So now if I do this, you'll see that if I just hit submit, you'll see that I connected to my Nakama instance. If I go to my Nakama console and I go to accounts, you'll see that we have an account right here that is my device unique identifier. And it actually builds a unique identifier for my user. So this can be nice if you're creating like a small game where people don't need to log in, but you just want to save their information, or if you want to have multiplayer, but you don't want any of the additional Nakama stuff. So the nice thing is if you had like a really simple multiplayer system, this can be an easy way to approach it. Now we have to store our data. So in order to store our data, it's really actually pretty simple. We'll come into here. We'll go down here. We're going to create a couple of buttons. That way we have, different ways that we can interact with that information. We have to be able to store it and retrieve that data. So we'll bring in a panel. We'll bring this guy down here like so. We're going to make it about yay big. We'll pull this guy up here. And we're going to right click add a child node. We'll add in a button. And we'll make it about this big, give or take. We'll duplicate that button and we'll pull it down. So we'll have one button that says store. So we'll say store data, and then we'll do retrieve data or get data. And then we'll say get data from store. That way we just have something that we can work with here. So store data. There we go. Now I'm going to come in here. I'll name this panel like a data panel or something like that, just so that I have a good name here. So data panel, like that. And what I'm going to do is I'm going to put this guy to be about the right size, give or take. And then I'll grab this guy, node button down. We'll throw it on our control node. We'll do the same thing for get data. We'll throw that on our control node. Now, in order to store data, it's actually really, really easy, thankfully. All we have to do is get the data that we want to store and then just send it out to Nakama, and it will automatically write that object. So what I'll do is I'll create the data here. So I'll say var save game, and we'll make that equal to quote, bracket, enter, name, colon, username, comma. We'll say items, and we'll make that equal to a object, right? And we'll say ID. One, comma, name, we'll say gun, let's say, so quote, gun, and then we'll say, let's say ammo, right? I'm just putting in some information here. So that way we have something here. Now I feel like we almost need to make this into a list of items. So we'll go ahead and do that real quick. So now we can just bring in here and then duplicate this. That way we have a little bit more of a complicated object to work with. And I'm doing this because I'm showing you guys just how complicated the objects can be. They can be crazy and you can make them really, really wild. So we'll do that, and then we'll hit comma, and then we'll have one more object, and we'll say it's called a level, let's say. We'll make their level 10. So once you create your object, which of course, if you want to make this scalable, you can just pass it in or go and fetch it from maybe your game state or something like that. And for the name of this, let's go with sword, and we'll go no ammo and ID of 2. That way we just have a little bit different information here. So when we want to store our data, all we really need to do is come in here and do what's called a write storage object. So we'll say var result is equal to await client dot write storage object async. We need to pass in a session, so we'll pass in our session. And remember, our session is our way to authenticate that information. And then we can pass in an object array. So you could actually store multiple objects all at once if you want to. In our case, I'm just going to go bracket, bracket, enter, and then I'll just pass in a Nakama write storage object dot new. And the first thing inside of here is what you're trying to save. So think of it kind of like this. You have a category and then like a subcategory, if that makes sense. So in this case, we'll just say saves, comma, and then we'll say save game, comma. We need to pass in can read, can write, the data, and then the version. And in the version, we're just going to make quote. Now you can see here, I'm doing 1 and 1. So what's going on here? So this is can read. This is basically saying the object that I'm trying to read, right? It's saying, can I read it once I save it? 1 means yes, 0 means no. Can write means, can I overwrite this object once it's been saved? Okay, so you could make it so it's read only. So that way the user could never technically remove or overwrite a saved game. You can make it so they can't do that by setting this one to 0. So this is if they can read it. This is if they can write to it once it's been saved. And the nice thing, you might be thinking, well, why would I ever want a non-readable data, right? Well, it's really nice if you want statistics on the server end. You could pass back statistics about the player, about their information, but never allow them to pull that data back. And that's kind of one of the big advantages to that capability. Now, when it comes to the data itself, it needs to be a string object. So let's JSON convert that. So var data is equal to this saved game, JSON.stringify, and then this game. So save game like that. And then we'll pass it in right here. So data like that. And that's basically all we have to do. Now, that being said, we probably should have some kind of exception checking. So if result dot is underscore exception, then we can print our error. So print error, and then we can just pass back our result. And we'll convert that to an str. Else, we can basically just say print, and then we're going to want to return because we don't want to continue the rest of our stuff because sometimes things get kind of funky. So we'll just return, and then we'll say print stored data successfully, like that. So now if I hit play, you'll see here, we're going to have I believe I did it under the right one. Let me double check. On store. Yep. So that's perfect. So store data, we'll click that. And we got an exception. So that's not a good sign. My guess is because I'm not logged in. So let's redo that real quick because we need to log in before we can do that. So let's go test@gmail.com. Password. We will submit. You'll see we get back our data, store data, and you'll see that we get stored data successfully. So now if we head back to our Nakama console and I refresh the page, if we go to their storage right here, you can see we have data that's stored for them right here. If we click on it, there's the data, and we can actually format the data so we can see it in a better way. So this is how we can actually store data out in the server, which is huge because it allows us to really gain the ability to store and save data. Now, how do we pull that data back? Well, thankfully, once again, it's really easy to do. Nakama makes it really easy. So if we go back to our client, we come down here to where our get data button down. It's basically the same thing. All we have to do is say var result is equal to await client.read storage object async, pass in our session, comma, and then what type of data we're going to put back. So get back. So if we do an array like so, because we can pull back multiple objects if we want to, you don't have to pull back just one. You can pull back as many as you want. So we can say Nakama storage object ID dot new saves, comma, and then the ID that we're trying to pull back. So remember, this is the category, this is the ID. So if we look at our Nakama console, the collection is save, the key is save game. So this must be save game for it to pull back that information. And then we can hit comma, and then session.user ID. And that's going to pull back our unique user ID. And the reason why is because if you look, this is their user ID. It's unique. It's very important to have. Now, how Nakama works is what it does is it takes this session user ID, validates it against your session, and verifies that you have the capability to have this information. And then once you do, it's going to return that data. So now we'll say if result is exception. I'll just grab this because may as well steal this information here. So bam, there we go. And then we will say for I in result dot objects, then print that data. So we'll print I dot to string. So str I, like that. And now if we refresh this, in theory, this should work. So we'll say test@gmail.com. I should probably default this, by the way, so we'll do that next. And we'll get data from store. And you can see here, collection, permission to write, and it pulled back that data as expected. If we actually throw a breakpoint here and we click get data from store, you can see that if we take a look at the data, so if we find our result object right here, go to inspector, you can see we have objects array size 1, and you can see that it's the object data right here, and it pulled back that data. And it's that simple. So if we want to pull back just that data, we could do result dot our objects, right? So you see how we're looping through here. 0 dot our value. Technically speaking, I believe .value will work. So .value should bring back just that data. So if I do that, test@gmail.com, I really need to default that. Submit, get data from store. You can see that it just pulled back just the data that we were looking for. So this can be really useful when you want to save user data, save user information. It can really be great for having a cloud storage instead of a local storage. The big advantage of having a cloud storage is that the data is not getting messed with by the user. You're forcing the data all into the cloud, so the only people that can hold on to that data is us, the actual server. So that makes things a lot more safer for it protects against a lot of hackers and things like that, or at least it helps protect against that. So that's one of the big advantages of this. Now, what happens if you want to store data in a different section, but under the same collection? Well, all you have to do is just change this ID to something different. So if I were to change this to save game 2 and I were to hit play and I forgot to default my email, I may as well just do that now while I'm here. So we'll come in here and we'll just say test@gmail.com and then password's going to be password. That way we can make it a little bit easier. So we'll hit play and we'll hit submit. We'll log in, store data, and then you'll notice that if I come out to my Nakama console and I go back to my saves, save game, I refresh, it should, if I go back to storage, there we go. It should show up right here. You can see it's under the same user ID, save game 2. It's the same information, right? We kept it as the same info, but we do have 2 different instances of that information. Now, what happens if we want to actually list what information we have available to us? Well, all we have to do is if we come in here, we duplicate this button here. We pull this guy down. Let's make this a little bit bigger, just a touch. And we'll change this from get data to list data from store. So list data from store. We'll change the title of this to list data, like so. We'll go to node, right click, disconnect it, right click, connect, and we'll connect that to our thing. To list our data, it's actually really easy. All you need to do is basically do exactly what we're doing up here. So basically go and fetch out a storage object, right? And it will list out that data. So we can say var data list is equal to Nakama API .api storage object list await client dot list storage objects async. We could pass in our session, comma, and then the type of information that we're trying to pull back. So the collection, so our saves, I believe is what we used. And then we can pass back the user ID. So it'll be session.user ID, comma, and then if we have a limit, so we can limit it to a number of values. So in my case, I'll just limit to 5, but basically what that's going to do is pull back the top 5 objects. And then all we have to do to list that data is basically come in here and say for I in data list print I, and that'll print out that information, if that makes sense. So now if we hit refresh, you'll see that when we click list data from storage, well, it got a little mad, unable to iterate on object. So if we take a look at data list and we take a look, that's because it needs to be .objects. So .objects like that, because you can see right here we have objects. So we'll pull that back real quick. We'll refresh and try that one more time. So we'll submit get list, and you'll see that we pulled back a bunch of our data. So it's useful if you want to get back multiples of an object type. So for instance, if you have a bunch of saved games and you want to get back all that information at once, instead of pinging out and getting each individual one, you can come through and list them and then get all of them back all at once. So that's the big advantage here. Now, This is all really cool, but how do we actually do matchmaking, which is basically the point of Nakama? Well, basically, in order to do networking, all we really need to do is we need to create a lobby name and then join that lobby. So if we come over here and we create another panel, like so, and we'll just put this guy over here somewhere, I think is fine. And we'll right click, add a child node. We'll add in a button. We'll make it about this big, put it right here. We'll add in a line edit like that. And this is going to give us a match name to join. So I'll actually create a label as well. And we'll make it about this big, give or take. So we'll just say name of match like that. And we'll make it about this big. We'll put this guy here and then we'll put it over here. We'll call this join/create, because when you join, you also can create that if it doesn't exist. So we're basically just going to do it that way because it's going to be a little bit simpler. And we'll have a join create match button right here. Now, inside of Nakama, there are two ways to handle matchmaking and multiplayer. And one of the things that people don't understand about it is that both of them have their advantages and disadvantages. I can almost guarantee you 90% of people are going to do one way and not the other way, just because it's going to be easier for your code and for how you structure things. So I'm going to create a small guy right here that just says ping, because that's going to allow us to ping some data. And I'm going to call this ping like that. Now I'm going to go to my project, debug, run multiple instances. I'll run 2 instances, and then I'm going to hook up our join create button like this. And I'm going to do the same thing for ping. I'm going to make sure that gets hooked up as well. Now, when we want to create a match, all we have to do is say var created match is equal to await socket dot create match asynchronous. And then we have to pass in a name. So it's whatever title you want it to be. In our case, I'm going to go with $ line edit panel 3. So we're making sure that's the same panel, line edit. So whatever data that's in that, and we'll say text. Now, of course, if you want to name this something, you can. So you could call it match name like that. And then you would just change this to match name to follow along. Now, once you do that, it's going to create the match and automatically join. Now, if we want to, we can come in here and say if created match dot is exception, then we can print out that exception. And we'll make that a str like that. And that's basically just going to say that we failed to create that match, and there we go. Now, if we successfully did it, we'll just say print created match, and we'll pass in an ID. So we'll just say plus ID, or I guess created match dot match underscore ID. Now, really what we should do, and I'm going to do a str to force this to be a string. Now, I know you could do this with compounding your strings by doing $, but typically this is easier for people to understand, is the little plus operator for this. Now I'm going to throw a breakpoint here so that way we can actually take a look at that information. So I'm going to hit refresh. You're going to see that 2 instances are going to come up. I'm going to log in and I'm going to say test, and I'm going to hit join create. And you'll see that if I come to this breakpoint, we successfully created that match. If we take a look at our created match object, you can see if it's authoritative, what the match ID is, the label of the match, if there is one. You can have presence, which is the number of people in it, the size of that match, and the user's session information. If I hit play and I let that run all the way through, you'll notice that if we go to Nakama console and we go out to status, we'll have a 1 session, 2 presence, and that's because we have 2 people currently playing a game or currently connected to our Nakama instance. If we take a look at our matches, you'll see we have 1 match that has 1 person in it. And that is kind of how you make matches. And now to be able to connect to that match, all we have to do is say test2. So I'm going to create a second user, submit. So I'm going to create an account. You can see the user account is right here. And I'm going to join the Actually, I think I put the wrong one. I did. That's unfortunate. So that's going to kill our match. So let me reset this. That is my fault. So we just logged out of our user account by accident. So let me go ahead and refresh and redo this. So test, and I will continue through that. And then we're going to grab the next one, which is right here. We're going to go test 2, submit, name of match, test, and we will click join. And you'll notice that if we look at our Nakama console, when we refresh, we have a presence count of 2. That's 2 people inside of that match. They're ready to play together. We can actually start the game at any time and their data would start synchronizing, which is awesome. And we also, if we look at our status, you can see we have 2 sessions, 4 presence, which means we have 4 people or 4 total types of data transfer. We have 0 authoritative matches and 84 Go routines. So that's kind of the power of Nakama, is that easily we have a match with people connected. So now the question is, okay, great. We have our connection, but how do we actually send our data across to each other? And that's where this ping button down comes in. And you'll also, just before we even do that, you'll also notice that we have a match presence event that is being fired. Every time somebody joins or leaves, these events are fired. So you could come in here and on match presence, you can see right here, we did that right here. We printed that presence. We could keep track of our users inside of that presence and actually say, okay, you know, so-and-so added the game, and we can actually add them up here. So that way we can keep track of what users are in our game on our client side. And that's really powerful for us when we do our networking. Now, granted, we're probably going to use the Nakama multiplayer bridge, so it's going to be handled slightly different, but I want to show you guys this way because it's important for you guys to know. So now, how do we actually send our data? Well, all we have to do is say var match. All we have to do is basically get our data. So var data is equal to, and we're going to do a quote hello colon world like that. And that's going to give us just a little bit of data, something that we can use to transfer our data. And then all we have to do is we have to go socket.send match state async. And then we have to pass in a match ID. So the question is, where's our match ID? Right? How do we know where our match ID is? Well, when we create our match, we create a title of some description, and that's in our $ label. I believe it was a match name.text, and that's our unique identifier that we can use. And then we have what's called a POP code. So what in the world is a POP code? And an OP code is basically an identifier that's not 100% necessary. You could put it as 0, you could put it as 1, you could put it as things like that. But it's a way for us to be able to denote what a thing is. So if we did like an OP code of 1, that basically just says this is a type 1, basically. And you can handle data differently based off of what that OP code is. Nakama doesn't necessarily care what the data is or what the OP code is. It's just kind of a way for us to define that information. If we hit comma, then we can pass in the data as a string. So we'll say data. And then we could pass in our presence, right? Which we don't necessarily need to. So I'm going to not pass that in, and I'm going to JSON stringify our data. Because remember, all of our data has to be done in string data. And now we have to catch that information, right? And in order for us to catch that information, we need to hook up our match presence, which we already did. If you scroll all the way up here, you'll see that we actually did, right? Let me see. There was somewhere in here that we did it, and I got to find it. Match presence right here. So if we refresh, you'll notice that when we submit and we do test and we join, and then we do test2 and test and we join. Well, it's mad at us. Let's see. Non-existent function create match async. Oh, that's because I didn't log in. Goodness criminy, every time. So we'll come back, submit, test, join, test2, submit. We are logged in, test, join, and then ping. And you'll see that we got an error. So that's not good. We got create pn dictionary invalid match ID code 3. So the question is, where did we go wrong here? Let's see. Now we got to debug our issue. Okay, so I think I figured out what's going on here. So if we take a look at created match, and you can see this little ID right here, we actually need to pass this in instead. So what I'm going to do is, instead of doing var created match is equal to socket create match asynchronous, I'm just going to copy this guy, get rid of var here. I'm going to go up to the top, and I'm going to go ahead and say var created match. I'm going to scroll down to where we're doing our ping, and I'm going to, instead of doing this text here, I'm going to say created match dot, and it's match underscore ID. I'm going to go ahead and save that. We're going to try that and see what that does. So we'll hit play. And if I log in here, so I hit submit, test, join, click, test2, submit, test, join, I will be in the same map. And then if I hit ping, you will see that we have a sending asynchronous request, receiving asynchronous request data right here. So that's basically how that works. So if we scroll up here, you can see inside of this section here on match state, I believe it's right here. If we run ping, you'll see it's going to pop into that breakpoint right here. And you can see the state object has a data parameter. So if I just put dot data, you'll see in a second, if I hit play, it should ping out just that data itself. So you'll see if I hit ping, you'll see that it just says hello world. And it's really easy to basically send data in that method. Now, the reason why I say that this isn't going to work for our stuff is not because we couldn't actually use it this way, because we absolutely could, right? We could go in and send the data like this every single frame, and that could be like our character position and stuff like that. But a lot of people want to use the multiplayer framework that Godot actually has built into it, right? Instead of seeing basically hello world or whatever our data is and then processing it and then running a function. Now, the way it would work, if I bring up Draw.io, so I can explain how this operates, just in case you guys decide to go this route on your own. So how this would operate would be, you'd have a match presence in like this, and then you'd have some kind of adapter here that would just say, if data type is 1, right, then we know that it's, a player info. So process player info like this, right? And then we would actually go and do whatever it is that we need to do. Let's say like add to game manager player info, right? And then if not, then if data is type 2, then we could say, oh, okay, that's the signal to spawn our players, let's say. So spawn players, right? If its data type is, let's say, 3, then we can come in here and say move players, or perhaps send player movement data. So it'd be like process move players, let's say, right? If it's 4, then that's like game over state, let's say. Something like that, right? So instead of doing everything through RPCs, we'd have to have a function that basically does this, more or less. And while that's good, and that's the way a lot of multiplayer operates, Godot has a built-in multiplayer system that actually works extremely well. So this may be more efficient, but it is much more complicated for developers to understand and for people to work with. So that's why the Nakama devs made it so that we can do what's called a multiplayer bridge. And a multiplayer bridge allows us to bridge our multiplayer, hence the name, and it allows us to actually set up a bridge to work with instead. So we could do things through RPC instead of doing this socket send match async and then sending the match data and processing it manually on the back end. We can basically just use Godot's built-in stuff. So the question is, all right, so you're telling me that the multiplayer bridge is better. So what do we need to do to actually do that? Well, that's pretty simple. If we scroll up to where our login is located here, when we do this, we can come in here and we can basically say, set up multiplayer bridge. Now I'm going to create a function to do that. So I'll just type set up multiplayer bridge like that. And I'm going to come down here and just create a quick function for that like that. And what I'll do is I'll basically just say, okay, var multiplayer bridge is equal to Nakama multiplayer bridge dot new, and I'm going to pass in my socket. Now this probably should be a global variable, so I'll actually just grab this guy, copy it, and I'm just going to go ahead and eliminate this and scroll up to the top. That way it just exists. It's going to be easier for me to reference it later if I ever need to. So I'll just do that. And what we'll do is we'll say multiplayer bridge dot match we'll connect some of our signals. So we have two signals we can work with. The first one is match join error and match join. So we'll come in here and say multiplayer bridge dot match joined error dot connect on match join error like that. And I'll copy this guy like this and I'll say func paste bracket, and we'll go ahead and pass this in. Now, when we do our on match join error, what it's going to pass in is going to pass in an error. So we'll put an error and we'll say print unable to join match plus error.message. That's going to pass back that message. And then we're going to do the same thing for our on match join. So we'll just say func on match join, and it's going to pass back nothing. So we're not going to have anything in here. So we'll say print quote joined match with ID plus multiplayer bridge dot match underscore ID. Because our multiplayer bridge is going to have that match ID, if that makes sense. And that's why if you look down here when we do our match join, we actually have a segment here where we're setting our match. We're not going to need to do that because multiplayer bridge is going to kind of handle a lot of that. So we'll need to go into our multiplayer section and kind of do some adjustments. But once we have these two signals hooked up, all we need to do is basically set our peers to be correct. So we can say get tree dot get multiplayer dot set underscore multiplayer underscore peer, and we'll set that to multiplayer bridge dot multiplayer peer. And what that's going to do is it's going to link our multiplayer bridge to our multiplayer peer. So it's basically just kind of connecting the two. So the Godot section works with the Nakama section, and the Nakama section works with the Godot section. It kind of creates that link between the two. And now we can just use our standard Godot on peer connected and on peer disconnected. So you should be able to say multiplayer dot on peer get tree dot get multiplayer. And actually, if we want to make this a little bit better, we could just say up here, we can come up here and say var multiplayer is equal to this, and then we can just basically reuse this. I think that'll be a little bit easier. There we go. Multiplayer dot peer connected, like that. And then we can connect that dot connect, and then we could just pass in on peer connected, like that. We'll just copy this and say func on peer connected, and that's going to pass in an ID, and then we could just print out that ID. So print like that. And then we could basically just do the same thing, but on peer disconnected. So we'll put in disconnected, and then I'll change this to disconnected, like that. I'll copy this. Actually, I'll just copy this whole function and go enter, paste, and then on peer disconnected. And then I'll say peer disconnected. And that should work. It's expecting a closing bracket somewhere. So let me see. It's missing the plus here, so that's why it's all upsetty. There we go. So we'll pass in that plus. We'll put a space at the end of this, so that way they match up pretty well. And basically all this is doing is it's setting up the multiplayer bridge. And then when we do our connection, we're going to need to make a slight small change. So if you look down here, if we can find it, on join match created, if we just comment this, Control K to comment, when we want to create a match or join a match, all we have to do is say multiplayer bridge dot join underscore named underscore match. And then we could just pass in our match name dot text like so. And then we can say, and that's pretty much all we need to do. And then instead of doing this for our pinging, Control K to comment, all we have to do is just do a regular RPC like you would expect. So if we come in here, we can create a function. So at RPC, any peer, enter func send data, like that. And then, well, I need a func, not a fun. We can say print, and we'll need to pass in some data. So we'll say message, and we'll pass in message like that. And then on here, we can basically say send data dot RPC, and then we can pass in hello world like that. And now if we've done everything correctly, it should just work. Granted, it probably won't, but we will try. So we're going to do that, test, join. You'll see it does that. We'll say test2, submit, test, join. You'll see peer connected with ID this. If I go ping, hello world. And that's how we can actually hook up our stuff so it all just kind of works with the Godot system. So it actually uses RPCs, which is awesome, right? That's something that's really big and really useful for us because we can make our stuff really easy to use for us, the user. And the Nakama team has done a lot to make it much better. Now, Nakama also has another way for you to be able to interact with their match system. So they actually have the ability to actually do matchmaking, which is really crazy. So how it works is actually pretty easy. What we're going to do is we're going to come in here, and instead of just joining a match name right here, we'll create another button. So we'll come in here, copy, paste it, and I'm just going to put it just below it. And I know it's probably not the best, but we'll go with start matchmaking. But it'll probably be easier than going through and building out a special system. So we'll just go into start matchmaking, and then we'll grab this guy, drag it underneath the panel, and then go right here, call matchmaking like that. And then we'll come over to our node. We'll go ahead and right click, disconnect, right click, connect, and we will connect it to our control node. Now, all we have to do matchmaking is actually come in here and create what's called a query. So a query is basically saying, I want these properties. So if we go var query is equal to quote plus, and that's basically saying add this parameter to my actual match, if that makes sense. And we'll say properties dot region colon, we'll say US space plus properties dot, and I spelled region wrong, so we'll fix that real quick. REGION, and we'll go properties dot rank, and we'll say I want your rank to be greater than or equal to 5, 3, well, I guess 4 plus properties dot rank colon, and I want it to be less than, let's say, 10. So this is really nice if you're trying to make a system where you're saying, okay, I don't want to match you with people that are too good or too bad for your game. So this can give you that kind of flexibility that you're looking for. And then we could say var, and for us to be able to do, and then we have to set our own properties, right? So when we do a matchmaker, we have to say, this is what our region is, and this is what our skill level is. Now, like I said earlier, this is generic, so you can actually do whatever you want. It doesn't have to be what I'm writing, right? You could do something like properties.game type is deathmatch, right? And that will work. So instead of region, you could do game colon deathmatch, right? And then that would be your property. And you can have as many as you want. You don't have to just do these two. You can have up to as many, I believe it's over, I think it's a couple million or something like that. So you really have infinite number of properties to work with here. So what we'll do is we'll talk. So you can see here we have US and then we have a 4, right? So Nakama separates the two based off of string properties and numeric properties. So I'm going to say var string properties. So string P is equal to bracket colon region US, like that. Then var and number properties is equal to bracket quote rank, and we'll say colon, and we'll make their rank a 6, let's say. So that should land us squarely in between these two values here. And then we basically just need to create what's called a matchmaking ticket. Now, again, you can have as many of these as you want. If you just separate them by a comma, then you could do something like rank colon 10, right? If you wanted to. Now, it doesn't have to be rank. It could also be, I guess in this case, you probably wouldn't do deathmatch here. You would do it up here inside of this region area. You would just say, comma, quote, match colon deathmatch, like that, and that would work. Now, in my case, I'm not going to worry about that right directly now, but just know that that is a thing. And then all we have to do is say var ticket is equal to await socket dot add matchmaker async. And then we have to pass in a query. By default, it just says all of them. So if you don't put anything in here at all, you'll just get matched with anybody. It could be any rank or anything or any amount of people. It's just going to do it. In our case, we have a query, so we'll do query. Now you also see that we have a max count, a min count, and if I get rid of this comma, there we go, we move this over a tiny bit. You can see by default it does 2 and up to 8 players. So again, if you had nothing in here, it would match you with a default of minimum 2 people and maximum of 8 people. So your lobby would only have 8 people unless you change it. In our case, I'm going to default it to 2, 4. Even though we're only testing with 2 people, I'll just set it to 4 just because it's going to be a little bit easier. And then you also have what's called string props. And if you have no string props, it's just going to not worry about it. But in our case, we do have string props, right? We made them right here. So string P, comma, and then numeric props. So same thing, number props, like that. Now we should check if there's an exception. So if ticket dot is exception, then we can just print out that we got an exception. And we can actually print out that exception. Like that. And then we'll want to return because we don't want to tell them that we did a good job, right, if we didn't. And then we could just print out that we have our ticket. So we could just say ticket number. And we can make that plus our ticket. And I'll just str that ticket like that. Now, when we do our matchmaking match, we actually have a signal that we can use for that. And it's called on matchmaker matched, or I guess it's received matchmaker matched, I believe. So we can come in here and just say socket dot received matchmaker matched dot connect, and then we'll pass in our actual function. And we'll say on matchmaker matched. We'll say func like that. And what it brings in is the Nakama matchmaker matched. So we'll say matched. And if you want to type that, you can just say Nakama RT API for real-time API, and then matchmaker, providing that it wants to do it. Matchmaker matched. And that should just give us a little bit more information. And now we basically can just join our match. So var joined match is equal to, not matched, match is equal to socket await socket dot join matched async, and then we can pass in that token, so matched. And then we can basically go ahead and set our match equal to our joined match, because I believe we have it up here somewhere. Created match. So created match is equal to joined match. I guess technically we should probably rename this to, just match is equal to match, right? Now, what I'm going to do is I'm going to uncomment these guys out because I don't want to hook up the multiplayer RTC. If you guys want to do that, you could basically just grab this bit here. And I believe multiplayer bridge, if I take a look at it real quick, it might not support it. So let me see. Because basically how this works is we're using a token to create a match. And since that token doesn't exist and multiplayer bridge doesn't support that, we have to use this section here to actually send data. So that's something to keep in mind. But now if I hit play, if I submit and I log in, I submit and I log in, and then I go start matchmaking and start matchmaking, you can see I have 2 tickets here. So I have match ticket number 1, match ticket number 2 right here. And then in a minute, it should pick up and detect each other and then combine each other. Now, by default, it has a minimum wait time or a maximum wait time of, if we take a look at our Nakama console here, if we take a look at this, we can go into our configuration and you can see right here, there is a match interval second right here, 15 seconds. So it waits a minimum time of 15 seconds before it says, yep, this match is good to go. You guys can send your stuff out. And the nice thing about that is that since it waits 15 seconds and then it does it 2 times, and then that's how it knows. So it takes about 30 seconds total before it says, yep, ipso facto, we're good. We have our connection. So that's how you can determine how long it waits for a match to show up. So if you've ever seen a game where it's waited for like 6 hours or something before it started your match, even though there was 8 people waiting or something, it's because their interval is really high and they're trying to make sure that they have a full lobby before they get into their game. Now, if we take a look at our project here, you'll see it says session ID match present event right here. That means that it successfully did what we needed. So now if we take a look and I run a ping, you'll see data is hello world. And that's because it fired off to this other guy here through Nakama and then send it to the other guy. And you can see here in our console, it will have sent that data across, which it should show up in the next minute or two. But that's basically how it all works in a nutshell. Thankfully, the matchmaking inside of Nakama is super easy to use. So now we've talked about how to do lobbies, we've talked about how to do matchmaking, and we've talked about how to actually store data inside of Nakama. So what else is there available to Nakama? Nakama has a built-in friend system, just right built into it, and it's super easy to use. So in order to do friends, what we need to do is we basically need to get a hold of their user ID and then basically send that out to allow you to connect them as a friend. Now, the way that I'm going to approach it is relatively simple. I'm just going to allow you to type in your friend's name and then have them get added. The reason why is because it's going to be a lot simpler than going through and actually querying all the users in the entire system and then displaying it and allowing them to add them. I think that's just going to be too much work. So what we'll do is we'll come in here, we'll right click, add a child node. Let's add in a panel. And we'll just kind of make it about this big. We'll put it over here and make it about this big. We're going to right click, attach a child node, and then we're going to type a line edit like so. And we will go like this. We'll right click, add another child node. We're going to add in a button. Now this button is going to allow us to add a friend. So we'll just add this, say add friend like that. We'll go in here and say add friend like so. And we'll say add friend text like that. Now, all we'll do is we'll just make this nice and big, get a nice little button here. And basically, we'll just allow the person to put a name in here to be added. Okay. And basically, we'll come down here, we'll click on this little add friend button, and we'll do button down and connect. And that's going to connect this to right here. Now, the nice thing about this is it's actually relatively easy on adding friends. All you need to do is you need to come in here and get some kind of ID parameter. So we'll say var ID is equal to bracket bracket $, add friend text dot text. And that's basically all we need to do to get back that information. We also can go by username as well. So we can go username is equal to bracket bracket, and then we can put inside some kind of username there. And then what we can do is we could basically go and add that friend. So we can go var result is equal to await client dot add friend asynchronously, and then we can pass in our session, and then we can pass in basically IDs. So if we want to pass in an ID, which if you look at Nakama, which I may have closed real quick, hold on. If you take a look at Nakama here, you can see if we go into accounts and we go into here, you have a username, a user ID, and a display name, okay? And what this requires right here is the user ID. Or if you pass in null, you can pass in the username right here. And actually, I should probably just get rid of that because we don't really need it. Now, this is going to be big for us because it's going to make it really easy for our users to add friends. If you take a look at the Nakama console here, they have a display name and a username. And all we need to do is use the username to add our friend. So if we go back here, we hit go, we hit the go button, and we log in. So submit, and then test to submit. So we have our two guys. User account is test, user account is test2. If we type test add friend, you'll see it's going to fire out that add friend request. Okay. Now this doesn't do anything. If we take a look at, I believe test2 was the person that fired off the friend request. You can see that it shows their name right here, test, but the state is invite sent. It's not accepted yet. So the only way for it to work is if the other person adds them back. So if test2 gets added, when we refresh this, you'll see that they are now friends. And that's how you make friends inside of Nakama. It's actually really simple to do. Now you might be wondering, okay, so how do I actually list my friends, right? Let's say I have friends because that's a thing. So to list your friends, all you need to do is come in here and basically fire off a get friend list effectively. So we can copy this, paste it. We'll come over here and bring it right here. We'll call it get friends. And we'll right click, disconnect, right click, connect, and we'll pass that into our button down here. Now, when we want to get our friends, all we have to do is say var friends is equal to await client dot list friends async. And then we can basically just pass in, and then we'll pass in session like so. And then we could basically loop through those friends and display them. So you could say for I in result dot friends like so. And then all we need to do is just print out our I, and that should print out our friends that we have. And I'm sorry, this should be result, because result, we don't want to do friends.friends. That doesn't really work. So we'll do results.friends. So if we refresh this and we log in and we click our left add friends, so we're going to need to rename that. If we click that, you'll see here, it's going to come back with our friends information. So it'll have their display name, it'll have their ID, it'll have their username and things like that. So it could be really useful for us. Now I'm going to rename this to get friends like so. And if we want to actually display our friends, let's say like a little panel over here, we can do that. Just copy paste. Let's grab this guy, grab these guys, eliminate them, right click our panel, add in a child node, and let's add in a VBox container. Let's make it full rect like that. And then let's expand this panel just a little bit. And what we can do is just instance a label right here. So we'll go into our script. We'll come in here and say for I in result friends, we'll say var current label is equal to label.new like that. And then we can go $ VBox container add child. And we'll add in that current label like that. And then we'll say current label text is equal to I dot, and if you look at our metadata here, we can get their display name. So I dot display underscore name. It's right here. So we'll grab this guy and we'll paste it like that. And in theory, that should work. So if we refresh this, we could basically just come in here and say get friends. And I didn't log in, so that's my fault. So let's log in. So log in, get friends. And it says that it doesn't exist. That display name doesn't exist. So if we go to I, it looks like user, then display name. So I.user.display name. So you can see how I got there. So I clicked on I, user, and then display name. So let's refresh that bad boy. Let's try it one more time. So do that, get friends, and you can see we have test2 right there. So that's their friends, right? So we could come in here, right click, add in a rich text label. Let's expand that to top center, go like that, and then type friends. We'll do BB code, so we'll do B bracket center, and we'll turn that on. And that should force it to go to center, but it doesn't want to. So if we put center first, there we go. So there we are. And then we'll just drag this guy down here like that. And there we go. And that'll just give us a nice little panel that just says friends. And then we can say get friends. And if we're logged in, it will work. We can click get friends and you will see that it shows right there that test2 is our friend. Awesome. So what if we're no longer friends? What if we don't talk anymore? What if I don't like this guy? He smells bad. Well, all we need to do is just remove them from being our friend. So if you want to eliminate a friend, all you have to do is first, let's create a button for it. So we'll expand this guy a little bit, and then we'll just copy and paste this. Our now friend is no longer our friend, so remove friend. We'll just drag this over a tiny bit. And then we'll come in here, right click, disconnect, right click, connect. We'll connect it right here. I'm going to rename this as remove friend beforehand, like that. And then I'll come over here to my button down. I'm going to do a connect real quick, and that will connect it right here. Now, all I need to do is do the exact same thing, but the opposite. Var result is equal to await client dot delete friends async. And you can actually pass in as many as you want. You want to pass in a session like so, and then you'll see here that you can pass in a pack string array, or if we just drag this guy over here, you'll see that there's also p usernames variant. So we'll pass in a null, and then we'll pass in our usernames, which in our case, just like how we added friends, we'll hit $, add friend text. And it looks like it's not going to let me pass in null, so I will pass in a bracket. Maybe that will work instead. Let's see if that's going to make it happy. We'll hit play, and then we'll hit submit. We'll type test2 remove friend. And then you'll see if we hit get friends, well, test2 still shows up. So I think something might have broke. Let's take a look at our console. Let's refresh. It looks like they're still there. They're still our friend. So we're going to have to go beat them up. So let's see what's going on here. So we're passing in our session. We're passing in that ID. I think it's because it's not a bracket ID would be my guess. I wonder if we can, let's try doing this. Let's try eliminating this and pass in that. Let's try wrapping it like this and then see what happens real quick. So we'll refresh, and then we'll try it one more time. So we'll submit test2, remove friend, get friends, and you can see they're now gone. We are no longer friends. They're not cool enough for me, so I took them out. They're not cool. So that's how you guys can add and remove friends. Now, you also can do what's called blocking, and that's where you stop people from even being able to communicate with you in any way. It'll also make it so that they should not play against each other in multiplayer either. So it's a really good way of eliminating somebody from the pool when you don't want to play with that person again. And how we can do that is actually pretty easy. If we grab our get friends, we duplicate it like so, and we pull this guy right here. We'll just kind of, I don't know, I don't really like remove friends. It's just such a long word. So how about delete friend? Maybe that will be a bit tighter. There we go. That's much better. And then we can just have a block friend, and it's still just a little tight, but that's okay. I guess it's close enough. We might be able to get away with it. So if we come in here, we change this to block friend like so. Come over here, right click, disconnect. Okay, right click, connect. And we click connect. Now, when you want to block somebody, it's the exact same way as we just did above here, but except it's blocking them. So if we copy this, paste it, we can come in here and just go block friends asynchronously. And now if we refresh this, if test does not want to talk to test2 ever again, we can click block friend. And what that will do is it will add them to the list of people on here as blocked, which means they cannot communicate with this person anymore. And the nice thing about that is that it basically removes them from the pool from that person, if that makes sense. And that's primarily all of the ways that you can interact and add friends inside of Nakama. Now, at this point, you have a basic understanding of how Nakama works. So what we're going to do, and you'll notice that some of this stuff got moved around. And the reason why is because I started launching into another topic, but I have about 2 hours of content at this point. So I'm just going to break this into a second tutorial, and then we'll just have two. So one will talk about the basics of Nakama, and then one's going to kind of move into more groups, parties, things like that. So that's kind of how I'm going to have to break this up. But what we'll do from here is I'm going to create a button here. So I'll pull this guy down, right click, add a child node. We'll add in a button like so. And then we'll make this nice and medium sized like this. And this is going to be start game. And that's how we're going to actually start our game. Now I'm going to go into our node button down, and then we will connect that. So one of the big things that people always ask is, how do I actually start my game? How do I actually make a game, right, with this? And since we're doing our multiplayer bridge right up here, right, with this join match, named match right here, since we're doing that here, what we can do is basically just use that and then do all of our RPC connections like normal. So what I'll do is I'll come up here. I'm going to add in a var players. And what that'll allow me to do is that'll allow me to actually get a hold of my players. Now, we could create a game manager to handle all of our players, and that's probably a good idea. But what we can do if we want to is just type static in front of this, and then that'll just make this a static variable, and then we can kind of work from there. So what we'll do is we'll come down to here. There's a section on peer connected right here. Peer connected is this. So what we'll do is say if not players.has, and we'll pass in ID like so. And then we'll just hook it in. So we'll say players bracket ID is equal to bracket, and then we'll pass in name peer ID like that. And then we're going to need to add ourself if we don't already exist. So if not peers.has multiplayer.get unique ID, then peers players.has ID or multiplayer dot get unique ID. Then we basically can add ourselves, because we need to add ourselves for us to be able to even work, right? So bracket multiplayer dot get unique every time unique ID like that, and we'll make that equal to bracket quote name, which I need lowercase n, name ID like that. Multiplayer dot get unique ID like that. Now, something to note, the reason why I'm doing it this way is because this gets me the unique identifier of our player on the Godot side. So remember how this works, right? So there's the Nakama side, right? Ooh, there we go. There's the Nakama side, and then there's the multiplayer bridge side. So this is the bridge. This is the Nakama, right? And both of these sides communicate to each other to an extent, right? So what happens is Nakama creates a lobby, connects it, and the bridge then creates its own lobby effectively, right? With its own unique identifier. So when people connect via Nakama, right, it's passing it to the bridge, and the bridge is adding them to the new project, right, to the new match. And that's how that stuff works. So it's just something to keep in mind, because it can get a little finicky sometimes when you're working with the multiplayer bridge. So you just need to keep that in the back of your head, if that makes sense. So in order for us to basically keep track of the players, we need to add it to some kind of thing, right? Now, we should also have a ready-esque system, so we can actually say, hey, I'm ready, I'm good to play the game. So when we hit start game, what we're going to do is we're going to ready up, and then we'll basically check if everybody's readied up, if that makes sense. So what I'll do is I'll come down here. I'll say func ready, and I'll pass it an ID, okay? And then what we'll do is we'll scroll up here, and I think I'm going to add inside of here ready, and I'm going to make it equal to 0. And then we'll do the same thing here. So quote ready, colon, 0, like that. So this is basically creating our player peers, right? And we're basically just making a state saying whether or not they're ready. We'll come down here and we'll say func ready with an ID. And we'll go players, bracket, bracket, ID, dot ready is equal to 1. And I'm going to make sure that I get the capitaling correctly. One thing it's not capital R, it's lowercase r. One of the things that is unfortunate about Godot is since it's not statically typed, you can kind of mess around and mess up your stuff. So it's just something to, keep in mind. Make sure you keep stuff correct and simple. Now, once we ready up, we need to be able to check if everyone's ready. And if they are ready, then we can actually get started. So we'll say if get tree dot is net multiplayer dot is server. And then what we'll do is we'll come in here and we'll basically say if our multiplayer is the server, then the server is going to check to see if everybody is ready. So we'll say for I in players. And what we'll do, actually, I think we'll say var ready players is equal to 0. So that way we default it to 0. And then we'll say if I dot, and you can see we have our ready up here. So if I find where our players are, ready. So we can say if I dot ready is equal to 1, then we can say ready players plus equals 1. And then we can check if, once all this is done, if ready players is equal to players dot, and I believe we could just use size like that. And then if it is, right, if we're good to go, then we can RPC out start game. So we'll just type start game like that, and we'll pass .rpc. And then from here, everybody can basically start their game. So I'm going to do func start game like that. And then we'll put in our code to start our game. Now, since we want to RPC, we need to do at RPC any peer, comma, quote, call local. That way we can call it locally as well, because we want our server to actually, call that. And same thing, we're here, we can just do RPC any peer call local, and we can do ready bracket bracket and pass in our ID. So multiplayer dot get unique ID, and that'll pass back our unique ID. So that's basically how this is going to work, is we're going to check if we're the server, then we're going to loop through, make sure that everybody's ready, and then if everyone's ready, we will start our game. Now, our game is going to be relatively simple just because I really can't build out a full multiplayer game just because there's a lot there. So what we'll do is, for us to start our game, we're going to need to create a new scene. So let's hit Control S. Let's go to scene, new scene, and then let's go and create a new 2D scene like so. And we're going to go ahead and add in a tile set. Now I already have one right here, which is kindly created by this guy here. It's a free set that we can use. I believe it's created by a person by Kanos. I'm not fully sure how to pronounce his or her name, but this is a really cool asset list that can give you all sorts of really good 2D art for your project. So go ahead and check this out. I'll leave a link to it in the description, and you guys can go ahead and download it from there. But once you have it downloaded and imported, we're going to right click, add a child node. We'll add in a tile map like so. We'll click on our tile set, add in a tile set. We're going to click on tile set down here, and we'll find the one that we're looking for. I think we're going to want to go with ground, and we'll drag that in. So you'll see that it's going to automatically create tiles in the atlas. Sure, we can try it, see if it works. So you'll see it's going to automatically detect and attempt to create tiles. Now, it looks like it's doing it in the wrong size format. The texture resolution is not quite right. It's going to be probably 32 by 32 would be my guess. And there we go. You can see that it reflowed it and it worked from right there. Now we do need to have it repaint all of this. So we can basically come in and just grab the eraser, come in and just basically erase out the areas that we don't want. Or of course, I believe there's a way to tell it to create tiles from non-transparent texture regions like that, and that will do it as best as it can. Now you can see there's a bunch of other stuff out here. This is just Godot not knowing what to do here, and that's fine. So we'll basically do that. We'll come in, clean this up, get rid of this because this is not correct. We'll grab the paint, or I guess it'll be the select, like that. And we will go ahead and do that. Now we still have quite a bit of garbage here that we can clean up, but we don't necessarily have to clean it all up if we don't want to. But I just like to make sure everything's nice and cleaned up. And there we go. Easy enough. So now once we have our actual set here, and we're probably not going to use 90% of this anyway, but it's just nice to have. We'll click on our tile map and we'll just come in here and change our size of our tile map to 32 by 32 right here, like so. And that'll just adjust our actual tile set. Now we can just grab these guys and just paint. So what I'm going to do is just do something simple. So I'm just going to plop that guy in there like that. And then I'm going to grab this guy. I'm going to plop another one like that. Give us a nice little bit of, a nice little bit here. And I'll just kind of drag this, grab it, and we'll just kind of plop that in like that. So that way we have some nice, nice cavern-y look to it. I don't want this to not be fully good, so we'll just kind of come in here and just plop that in, and we'll do the same thing here. Just drag that guy down. And actually, I don't want, I'm being a bit of a perfectionist, my apologies. But we'll just clean these edges up a tiny bit. We'll grab this one, clean that edge up a tiny bit. Grab this one, clean up this edge just a little. There we go. Just to help clean it up and make it look nice. There. Not too bad. So that will give us two big, basically, pillars. And what I'm going to do is make all this navigatable into our physics layer. We're going to add a physics layer here. You can see I have a collision layer and a collision mask here. And if you want, you can add a physics material if you'd like, but you don't need to. And then what we can do is go into our tile set right here, click on our tile set, and then go in and select the tile sets we want collision. So, and then come in here, go into paint mode, select this right here, go down to physics layer, and then just drag. And that will go ahead and make these guys collidable. So you can just kind of come in here and paint in how you want everything to be collidable. Now, thankfully, once you set this up, it's relatively quickly to get it to work, but just know it can be a bit of a pain to set up right offhand. So we'll come in here, we'll kind of paint all these guys so that they have collision and proper collision, like so. And if you want like something like this to have less collision, you could just come up here and then drag these guys like this, and then that would get rid of the collision all the way down there. So that's something to keep in mind, is that you don't have to force everything to have perfect collision. So like if this guy here has collision like so, you can actually come in here, pull this out so it's fully collidable, and then add in an additional point here. Well, providing that Godot wants it to work properly, we can go in here, select like this. And it should work, but it's not very happy with me. There we go. And then we can just kind of move this guy up, and then there you go. So you can get a more complicated selection like that if you wanted to have a more complicated collision system. In my case, I am totally fine with having the standard collision system, but I just wanted to let you guys know that that is an option for you inside of here. Now, once we have everything that has collision, we can basically test this. All we need to do to test this is go into our tile right here, right click on a node, add in a child node, add in a rigid body. We're going to right click, add in a collision shape 2D. Go in here, click on this guy, and let's just drop it a nice circle like so. We'll make it about this big, give or take. We'll just drag in the Godot icon like this, and then we'll change the icon to be just a touch smaller so it just kind of fits inside of here. And then we'll grab our rigid body like so and drag it like that. And then we'll hit play. And if it asks you to save, go ahead and save. And there you go. So now we know that this is going to work, right? Because it's now colliding with the floor. So we know that it's going to work. So at this point, we're ready to actually start building out our actual game. So let's build out a small basic player controller. So we're going to right click, add a child node, and we'll add in a character body 2D. We're going to right click, add a child node. We'll add in a sprite like so. And I'm just going to make it the Godot icon. And I know that it's not super fancy considering we have a nicer, fancier little icon tile set here, but I'm just trying to show you guys how this works and stuff like that. So we'll come in here, we'll drag this guy here and drop him, I don't know, somewhere right here. We'll right click on our character body, we'll attach a script, and we're going to go ahead and call it player.gd. And then we're going to right click, add in another child node, add in a collision shape 2D like so. And then we'll click on this guy and throw in a new rectangular shape. Now I'm going to make this rectangular shape just a little bit bigger so it encompasses my entire Godot icon here. And then I'm going to right click, attach a script. We're going to call it player.gd, providing I can spell player. There we go. And we'll have our basic character movement script attached to it. So we'll hit create. And this is going to basically handle most of our stuff right here. So if we hit play, you'll see that now we have a small character script that works. So our character can run around and do things. Now this isn't quite centered, so that's going to really hurt my soul. So let's quickly fix that. So we'll click on this. We'll come in here. We'll zoom out. We'll take a look at this. Grab our tile map and just kind of pull it over. I mean, it's not super ideal to just yank this guy over, but we'll do that so that way we can center this up a tiny bit. Now, when we do multiplayer, we need to be able to synchronize our character code. So we'll go into our code here. And what I'm going to do is I'm going to write a bit of code that's going to allow us to control this character if we are the proper ID. So the way this is going to work is going to be pretty simple. Basically, we're going to check our name and see if our name is the proper name for our unique identifier. So what we'll do is we'll say if name is equal to get multiplayer dot get unique ID, like that. And basically, if we are our unique ID, then we know that the client is the proper person, if that makes sense. And then we could just say str like that. And there we go. So our character's name is going to have a unique identifier, and that unique identifier is going to identify the client that that player is from, if that makes sense. And then we'll come in here and we'll basically synchronize our position. So we'll say sync position, and we'll pass in our position. So we'll say global position like that. And we can't just run sync position because it doesn't actually exist, right? So we got to make that function. So first things first, since we're going to be doing a sync, we're going to RPC that data across. If you remember, we talked about that with remote procedure calling, and then we'll create that function. So func sync position, and we'll pass in position. And actually, we should probably just pass in P. And then we'll say global position is equal to P, like that. And then we'll hit at RPC, any peer, and there we go. Now we don't want to sync this locally. We don't want to run this locally because we're already doing this here. So we're already doing the moving right up here. So we don't want to necessarily have it do that. Now, the reason why this exists is because we don't want people to be able to control other people's characters. We only want to be able to control our character. So that's what this is for. And then this will sync across our actual position. So now at this point, we basically have our character controller handled. And I'm going to name this as player like that. Now I'm going to make this into a reusable component. So we'll just drag this down to RES and we will save this as player. And now we need to actually get our spawning system to work. So when the players come in, we need to be able to spawn out all of our players. So what we'll do is we'll right click on our node, attach a script, and call it scene manager like that. Now our scene manager's whole job is going to be spawning the players and putting them in the right spot. So we need to do two things. One, we need to get a hold of which people need to be spawned, and we need to be able to figure out where they got to spawn. So the simplest way to figure out where they have to spawn is by basically creating spawn points in your world. So I'm going to right click, add in a child node, and I'll add in a position, which it looks like they removed. So let me go into node 2D and let's see what they call it now. I am not seeing anything in here for position 2D. It used to be a thing, but apparently it's not. So we're just going to drop in a node 2D. We'll call this spawn point like that. And I'll drag this over here. I will duplicate it and drag this over here. So we have two spawn points. I'm going to grab both of them and assign them to a group. And the group is going to be called spawn point. Like that. There we go. And then I'm going to come in here and on ready, I'm going to get all those spawn points. So I will create a variable up here called spawn points. And then I'll come down here and I will say spawn points is equal to get tree dot get nodes in group spawn point like that. And I believe it's just spawn point. So we'll make sure by copying and pasting it. And there we go. And that's just going to give us all the spawn points that we need. And then we need to get a hold of our players. So all we need to do is basically say for I in, and we need to get a hold of our actual players. So if you take a look at our code here, if we scroll up here, we click on this guy, you can see if we scroll up, this is called Nakama multiplayer. So we'll say Nakama multiplayer dot peer players, then we can spawn those players. So we're going to need a player scene of some description to spawn. Thankfully, we have one. It's right here, right? We created it. So we can do @export var player scene, and we're going to make that a type packed scene like that. And then we can basically spawn our players. So var instance player is equal to player scene dot instantiate like that. And then we can set our name. So we can say instance player dot name is equal to str Nakama multiplayer dot players bracket I dot name. And that'll pass back their name. And then we can add that as a child. So add child and then instanced scene, or instanced player in this case. And now we need to actually spawn our player. So thankfully, we have a list of players right here in our spawn points, right? It's an array of spawned objects. So we could basically just say instanced player dot global underscore position is equal to get node spawn points bracket index dot global underscore position. And since this is an array, we actually will probably need to start with an index of 0 instead of an index of 1. And then we can just do index plus equals 1. And that will go ahead and set up our stuff. Now, from here, in theory, this should just work. So if we click on our node 2D here, we go over to our inspector, you can see we have a section for our player scene. So what we'll do is we'll drag our player scene right in there. We'll control S. we're going to go out to our test scene and we're going to load that test scene when you click the ready button. So we'll come in here and we'll say at packed scene, export var multiplayer scene. We'll say colon packed scene like so. And we'll scroll down. And then when we start our game, we're just going to go ahead and instance our scene. So much like what we did here, where we're instancing the player, we're going to do the exact same thing. So we'll come in here and we'll say multiplayer scene dot instantiate, and then we'll need to add it as a child to something. So you can see here that we have this scene here that has like all of our multiplayer stuff. So what I like to do is I like to make a new scene. I like to make a 2D scene, and I'll just call this my game manager. And basically the game manager is going to house those scenes. So I'll hit Control S and I'll just call it game manager.tscn. That's totally fine. And I'm going to drag in this test scene into my game manager scene. So we'll just drag this guy in here and there we go. And then I can drag in my multiplayer scene here. And actually, now that I'm thinking about it, because I'm kind of braining this out on the fly a little bit, what I'm thinking is actually if we come in here, I wonder if we should emit a signal instead and go ahead and not instance this underneath our scene. I think that's going to be a better route for us. So what I'll do is instead, I'm going to Control X this guy. I'm going to come into my game manager, right click, attach a script. We'll call it game manager.gd. We're going to paste that script in. And then we'll basically say on ready $control dot, which I don't really like control. So we'll rename this as UI. And then we'll say $UI. And we'll go ahead and create a signal inside of our scene here. So in order to create a signal, what we have to do is just type signal. And we'll say start game, like so. And then what we can do is we can come down here and we can go ahead and do start game dot emit. And that's going to fire off our start game scene signal. Though we already have a function called start game, so I think we're going to need to rename this to be on start game. That way it has some kind of definition here. So we'll do on start game instead, and that will emit that signal. Now, once we do that, we'll come into our game manager. We'll hit UI.onStartGame.connect on start game, and we'll make a function called func on start game like that. And then all we'll do is we'll basically just paste what we were doing over there. So we'll just say multiplayer scene dot instantiate like that. And then in theory, and actually I should probably lowercase this O, so that way it defines it as a private function, if that makes sense. And then what we'll do is we'll right click our game manager. We're going to make a node 2D. We'll call it multiplayer scene like that. And then we'll basically just come in here and go $multiplayer scene dot add child, and we'll add this as our child. And that'll basically just add it as a child. It'll instantiate it, and it'll put it underneath this guy right here. And that's going to make it really easy for us in the future. If we want to make this into a bigger project, we can go in here and delete and instance whatever we want and still maintain all of our variables and all of our data that we would expect. And we also can come in here and hide our UI. So $, so hide like that, and that'll just hide this UI. And from here, in theory, that should just work. So we'll come in here, we'll hit play. And this is going to not work because I need to go into the game manager and hit play. So we'll refresh that guy and run it one more time. So we'll submit. We'll do test 2, submit, test, join, test, join, start game, and then start game. And you'll see that it is attempting to run. Now you can see here that we do have a slight issue here. So we have any peer ready if ready is equal to 1. Ready is not available on base int. That's my fault. So our players need to come back with a object. Unfortunately, that confused me a little bit because inside of C# it comes back with that object, but in this case it doesn't because GDScript doesn't do it that way. So we'll go ahead and do that, and I'll take a look to make sure that there's nothing else in here. I think we're okay. So we'll refresh this and try it one more time. So we'll submit, test, join, test 2, submit, test, join, start game, and then start game. And nothing happened. So that's not a good sign, but let's see what's going on here. So if we look at our remote here, we take a look at our game manager. Our scene never got spawned. So I'm curious if this even fired. So let's go ahead and do start game. Okay, so start game. So that didn't work. It should have, but it didn't. So let me see. Players.size is going to be, let's see. And unfortunately, it's not going to let me go with what my player's size is. But Godot says it's not the same size. So let's see. Okay, so I figured out what the issue was. Now we're in another issue here. But you'll see in about 5 seconds when I go over here and I take a look at it. You'll see I put a bunch of logging in here to kind of try to figure out what's going on. But basically, if I pull the logging out, all of the logic here is actually correct. All this is fine. Up here, we were not calling RPC. We were just calling it locally. So, of course, it's never going to work, right? Because we're not RPCing the data across. We're not sending it to everyone else so that they know that our state is ready. So, of course, it's not going to match up because we didn't know that everybody was ready and good to go. So that's the reason why this became a problem. So now the question is, what else broke? Well, you can see here, it says cannot call method instantiate on a null value. Now, the reason why this is null is because if we go to our game manager and we click on our game manager, you can see the multiplayer scene is empty. So let's add that in. So we'll put this guy in like so. We will refresh, and we're already going to run into an issue before I even get started. Let's take a look at our node 2D. You can see we have a player, so let's get rid of that. We don't need a player to exist in our scene. Now, if we go into our game manager, we hit play. If we log in, test number 2, log in, test, join, start game, start game. And it's still mad at us. Cannot call add child on a null value. That's also my fault. Capital M, not lowercase m. I don't know why Godot didn't pick that up, but I probably made the mistake, not Godot. So we'll go ahead and just make sure that that's correct. We'll refresh. We'll try this hopefully one last time. So submit, test 2, submit, test, join, start game. And you'll see that we have both of our nodes here, like so. And you can see if I make him move around, it works. Awesome. And if we come in here, we could do the same thing. You can see it works. We do have one slight issue where for some reason our player is spawning in the wrong spot. So that might be a problem because you can see we have 1 and 1. And my guess is it's going to be an order issue. So what's going on, and this is just a guess, not an actual statement because I'm not fully sure, but what's going on is because one person on one side has its dictionary set up in one order and then one has their dictionary set up in another order, that they're conflicting. And what I mean by that is if you were to take a dictionary, let's say, so let's just come in here and I'll explain it. So you have player 1, right, and player 2. And this is what the server has, okay? But the client has player 2, comma, player 1. And this is what the client has. So then what happens is when one of these guys gets spawned, the data starts synchronizing, and then that player gets sucked to the other spawn point. And that's what causes this issue. So we need to actually organize our list before we start doing our spawning. And that's actually really easy. It's a little bit painful, but it's pretty easy to deal with. So if we come in here, all we have to do is say var keys is equal to Nakama multiplayer dot peers players dot keys, like that. And then we can just type keys dot sort, and that will sort all of our keys in the correct way. And then all we have to do is say for I in keys, then do all of this. And it should just fix our issue. And the reason why is these keys take that player like 1, 2 and makes it and 2, 1 and makes it into 1, 2, 1, 2. So that way everybody is consistent and using the same order as everyone else. So now at this point, this should work. So if we come back to our test scene, we hit play. Or I'm sorry, not our test scene. If we go to our game manager, we hit play. We'll submit. We'll go to test 2, submit, test, join, start game, and start game. You'll see that we both start on the opposite sides of each other. And that's basically the basics of multiplayer in Nakama. Now, I know that we didn't cover everything, and that's because there's so much information inside of Nakama that it's really hard to cover everything in a single sitting. We're probably looking at almost 2.5 hours right now for our game. And you can see right here, we're actually RPCing at 120 frames per second. So we're doing 120 RPCs per second. So that's a little bit on the high side. You can see it's about 35 kilobytes of information. It's a little high. It's a little too much, but that's okay for now. We can talk about, different synchronization methods and things like that later, or ways to optimize this later. But just know that that's a thing, right? It's just something we'll have to look at. But what we talked about was how to do accounts. We talked about how to do storage. We talked about how to handle matches and matchmaking. And in the next tutorial, not the C# one, but in the next one after that, we'll go through how to do leaderboards, how to do chats, how to do groups, and how to do parties, because those are all really important things, but it's just going to take a lot more information for us to put it all together, if that makes sense. And one of the big things that I will also be covering is how to build custom modules for your server, because that's one thing that I missed in the previous version of this tutorial series. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button, because I'm here to make content for you guys. This video was a viewer suggested video. And if you have any suggestions, please leave them in the comments below or hit me up on Discord. Link is in the description. I'll be more than happy to help you out. That is all I have for you guys today. So thank you so much again for watching. I will see you all next time. Thanks.